Good day, viewers. My name is Agali Belinda Chizob. I'm taking on the subject chemistry and the topic hardness of water and water pollution. By the end of this lesson, the students should be able to define hard water, list ions responsible for water hardness, state advantages and disadvantages of hardness of water, list ways of removal of water hardness, list sources of water pollution, and state ways by which water pollution can be controlled. Hard water is a water sample that does not produce lather easily with soap, while soft water is water sample that produces lather easily with soap. Hardness of water is due to the soluble source of calcium, magnesium, and/or iron in wells, rivers, and seas. You might be confused which water does not produce lather easily with soap. Try to compare washing with well water or borehole water and well washing with rainwater. The rainwater will easily lather with soap, while the borehole water will not lather easily with soap. There are two types of hardness of water. We have temporary hardness and permanent hardness. Temporary hardness is caused by the presence of hydrogen triisocarbonates 4 of calcium, magnesium, or iron. That is, calcium hydrogen triisocarbonate 4, magnesium hydrogen triisocarbonate 4, or iron hydrogen triisocarbonate 4. Temporary hard water is formed when rainwater that contains dissolved carbon dioxide flows through a locality where there are deposits of limestone or chalk. The carbonated water is a weak acid. It dissolves the limestone or chalk to a solution of the triisocarbonate 4 salt. You can see here limestone plus CO2 and H2O in rainwater to give us the soluble salt that is present in temporary hard water. Permanent hardness is hardness which cannot be removed by boiling. It is due to the presence of tetrahydrosulfate 6 or chlorides of calcium, magnesium, or iron, that is, calcium sulfate, magnesium sulfate, iron 2 sulfate, calcium chloride, magnesium chloride, or iron 2 chloride in natural water. Although calcium sulfate is only slightly soluble in water, its solubility is high enough to cause permanent hardness. Generally, samples of natural water from rivers and wells, except rainwater, have varying degrees of temporary and permanent hardness. Disadvantages of hardness. Hard water wastes soap. Soap used in hard water produces what we call scum first, before further addition of soap starts to produce a lather. When hard water is boiled, it causes insoluble calcium carbonate to deposit in kettles and boilers. The deposit forms scales in boilers and fall in kettles. What we refer to as scales in boilers, when you buy a boiler new, it's shiny. It has this silvery shining, but after using it for a long period of time, it turns to brown. The same occurs in kettles. Such deposits will block water pipes, and being a conductor of heat, the deposit of calcium carbonate results in more heat required to boil the water in a kettle or boiler. Hard water is not suitable for use in laundry, textile, tanning, and paper manufacturing because it damages dyestuffs from fabrics. Dyestuff simply means the color on the material or the textile or the paper manufacturing. Advantages of hard water. Hard water provides calcium salts used in the manufacturing of food in plants. Calcium salts are also used in the formation of shells by some water animals like fish and crabs. Hard water is also suitable for use in the beer brewing industry because of its characteristic taste. Calcium salts are necessary for the development of strong bones and teeth. When calcium hydrogen triisocarbonate 4 decomposes, it produces pure calcium carbonate which is used in making cement, quicklime, etc. In caves, you can get pure pillars of calcium carbonate that has been deposited when water containing calcium hydrogen triisocarbonate 4 falls in drops on the floors of the caves. These deposits will grow and with time form stalactites, which is the downward growth, and stalagmites, which is the upward growth. These stalactites and stalagmites can be collected and used in the manufacture of cement. Removal of hardness. The following methods can be used to remove hardness of water and hence obtain soft water. Temporary hardness. You can remove temporary hardness by boiling. The hard water is boiled in order to decompose the hydrogen triazocarbonate 4. However, this method is not economical since it will waste energy. Addition of slaked lime. On a large scale, calculated amounts of slaked lime is added to the temporary hard water to precipitate the insoluble calcium carbonate. Another method is addition of washing soda. On a large scale, sodium triazocarbonate 4 crystals, which is washing soda, are added to the water sample in order to precipitate calcium carbonate. Permanent and temporary hardness. Temporary and permanent hardness can be removed at the same time by the following methods. A is addition of washing soda to the calcium sulfate in hard water to precipitate the calcium carbonate and form the insoluble sodium tetrahydrosulfate 6. Another method is by distillation. The hard water is boiled and then the vapor is cooled in order to obtain distilled water. The residue is left in the distillation flask. By use of ion exchange resin. A chemical called aluminum tetrahydrosilicate 4 or NaR, known as a cation exchange resin, can be used to make hard water soft. While hard water is allowed to pass through sodium permeate, it exchanges its own ions with calcium, magnesium, or iron 2 ions present in hard water. This is called a double decomposition reaction. The water that comes out is soft. It is free of the ions causing hardness. You can see here, this is the ion exchange resin, while this is the permanent hardness. They just exchange the ions, forming sodium tetrahydrosulfate 6, and then the calcium with ion exchange resin. Cation exchange resins are widely used in the industry. They are called deionizers since they can remove ions present in a water sample. However, they are not capable of removing harmful bacteria or non-ionic organic matter in a water sample. Water pollution. Water pollution occurs when certain substances that are harmful to living things are present in high concentration in the natural sources of water. Water pollutants include the following: atmospheric solid and gaseous impurities. These include dust, soot, carbon dioxide, sulfur dioxide, hydrogen sulfide, and oxides of nitrogen. When rain falls, the rainwater washes from the atmosphere solid and gaseous impurities into the water bodies. The rainwater may be regarded as a very dilute solution of triazonitrate 5, triazocarbonate 4, and triazosulfate 4 acid, or what we refer to as acid rain. Most of us have heard of acid rain before. That means that almost all rain that falls is acid rain. But acid rain can remove or date sculpture materials, sewage, and human waste. These are usually dumped on open grounds or directly into rivers. There are some people that live on the rivers that dump their waste directly into the rivers. These wastes are organic matter, which can be decomposed by bacteria into harmless material. However, during this process, the bacteria uses up the oxygen dissolved in the water, putting fish and other aquatic organisms in danger. This type of water supply becomes contaminated by harmful bacteria and acquires unpleasant odor and taste, making it unfit for domestic use. Fertilizers. Triazonitrate 5 and tetrahydrophosphate 5 compounds found in fertilizers are soluble in water, and when they are washed into water bodies, they enrich the water. That's what we call eutrophication, promoting growth of algae and weed. When the algae and weed die, they are decomposed by aerobic bacteria, which will also use up the dissolved oxygen, thereby endangering aquatic organisms since they won't see dissolved oxygen to use. Industrial waste. These are made up of metal scraps, plastics, and chemicals from various kinds of industries. These wastes contain compounds of lead, mercury, acids, alkalis, dyes, chlorinated solvents, DDT, nitrate ions, and phosphate ions, and so on. All these chemicals I've mentioned and these wastes are non-biodegradable, or some are slow to degrade. They can be washed by rainwater or dumped by the chemical factories into wells and rivers, thereby polluting the water supply with heavy metal ions such as mercury and lead, which are poisonous to fish and other aquatic organisms. Crude oil spillage and radioactive waste. When there is crude oil spillage in a body of water, the resultant effect is the reduction of oxygen level in the water bodies, thereby endangering the survival of marine and aquatic lives. Radioactive waste from nuclear reactions are usually dumped into seas. Such wastes are harmful and are difficult to dispose from the seas. Litter. Litter such as waste paper, plastic containers, and food and drink cans is sometimes thrown into rivers, open drains, and beaches. Aquatic animals can swallow this litter and choke to death. Control of water pollution. Water pollution can be controlled by burying and burning of refuse. Most of us are guilty of this charge of causing water pollution. We can bury and burn our refuse so that we can control water pollution. Treatment of sewage and industrial waste in order to remove the pollutants before discharging. We can also convert chemical waste into biodegradable matter before being disposed. Recycling of solid waste can control water pollution, and proper monitoring of the treatment and disposal of industrial waste by environmental agencies. Evaluation. Since we have come to the end of the lesson, we have to evaluate ourselves to know if we have actually learned anything. Number 1 says we should define hard water. What is hard water? Hard water is water that does not lather easily with soap. List 2 types of hardness in water. We have temporary hard water and then a permanent hard water. Number 2b says we should name 2 salts responsible for each type of hardness. Remember that the salt that is responsible for temporary hardness is different from the one that is responsible for permanent hardness. For temporary hardness, we have calcium hydrogen triazocarbonate 4, magnesium hydrogen triazocarbonate 4, and iron 2 hydrogen triazocarbonate 4. For permanent, we have sodium sulfate, magnesium sulfate, calcium sulfate, and iron 2 sulfate. Number 3, what is the effect of hard water in laundry? It will remove the dye stuff present in our fabrics. Number 4 says we should explain why temporary hardness of water results in the thawing of kettles. Remember that when you boil hard water in kettles, it will deposit the insoluble calcium carbonate, and that is what causes thawing in kettles. State 3 methods of removing temporary and permanent hardness at the same time. We have addition of washing soda, distillation, and use of ion exchange resin. Number 6, name 2 gases associated with acid rain. We have sulfur 4 oxide and carbon 4 oxide. Suggest 2 methods of water pollution control. 1, we can bury and burn our waste. Environmental agencies should charge industries to treat their waste before disposing. And then list 3 sources of water pollution. We have atmospheric pollutants, we have sewage, we have litter, we have industrial waste, and we also have fertilizers. We have come to the end of the lesson. Thank you for listening.